I want to show you how we can create some interesting effects using the pixels array. This is the program we created in the last episode. This is what we see when we run the program. And what we are doing is completely filling the screen with pixels. And each pixel has a random shade of gray. So in this program here, we completely ignore what we had before on the screen. We just fill the whole screen with a new set of pixels and erasing whatever we had before. This is sometimes fine, but I think most of the interesting effects we can create are accomplished by modifying the image we had before, not completely destroying it, but changing the properties of each pixel. Let's see how we can do that. So let's start here with this program, and the first thing I'm going to do is load an image, so we have something to display. This is going to be a pImage variable. I'm going to call it img, and I'm going to load this image called big.png. So I have to add this image to our project. I'm going to click here, and now that we have added the image to the project and that we have loaded the image, I'm going to display the image on the screen. I'm going to say here image img, and I'm going to show it at position 0, 0, so on the top left corner. So now we can run the program and just see that it's working. So we have this image that completely covers the screen. So we have seen that when we want to manipulate the pixels, the first thing we have to do is to call load pixels. And here we will do some changes to the pixels, and finally we will call update pixels to copy all those pixels back to the screen. Okay, so now let's create here a for loop, and let's go through every single pixel in our screen. So I'm gonna say int I is 0, while I is less than pixels.length, then increase I. And now we know that here we can access the pixels by calling pixels and square brackets I. So I have to change this. Before, what we did was to set here some random color. Let's start here by saying that we are gonna create a new color which will have some amount of red, of green, and of blue. Now we have to define R, G, and B. So I'm gonna say here float R, float G, and float B. What are these equal to? I said it would be nice that we don't erase completely the image, but we change it somehow. So let's start by making an exact copy of the old image. We can achieve this by using these functions we have never used before: red, green, and blue. These three functions extract the red part of a color, the green part of a color, or the blue part of a color. So I can say, take the red part of the pixels I. So pixels I here is the current color of the pixel. And this is telling processing, I want to know how much red is in this color. We know that we can define a color like this. Color C is color 11, 33, 50, or 66. If we would call here, give me red of C, what we get is this 11 here. If we would type green of C, then we are getting this value here. And you can imagine what we get when we call blue of C. This is just to show you an example. We don't want to make the whole screen use this color, this 11, 33, 66. Instead of C, we are going to type here pixels I, which means whatever color this pixel had until now. So all these lines actually achieve nothing, because what we're doing is reading from the current pixel how much red, how much green, and how much blue there is, and then we build a new color with exactly the same properties. So if we run the program, we're gonna get exactly the same. But the fun thing is now I can easily remove one of these. For example, I can say this color has no more green, only red and blue. And if I run the program now, this looks like magenta. I can also say I don't want any blue here. So this means save the red part of the original color, but just replace the green and blue with 0. This in some programs is called the red channel. Like in Photoshop, there is a red channel, a green channel, and a blue channel. If you want to see one of the other channels, we can see, for example, the green one. And here we are saying that don't take any red or any blue from the original color, just take the green part. So this is how it looks like. Another experiment we can do is we can take the red, green and blue, but we can swap them. We can say use the blue for the red component and use the red for the green component and use the green for the blue part. So we are changing the channels. Probably we are totally destroying the original colors and we are getting this kind of green here. We can also try by repeating some. For example, we can say try red and green, and we are not using the blue for anything. Now it looks kind of yellowish. We could also try using the red component for all red, green and blue. And we know that when we use the same value for all three, we get a grayscale image. So this is a grayscale image based on the red channel. If we use one of the other channels, we will also get a grayscale image, but it might be slightly different. This looks darker. This is happening because the original image has more red here and very little green. Let's try with blue. This looks quite similar to the red version, maybe slightly darker here on the right side. So this is one way we can read the data from the original pixel. We are reading how much red, green and blue it had, and then we are using these numbers to build a new color. There's really like millions of possibilities of what you can do with these numbers, because they are just numbers. So you can multiply them, add them, divide. You can use randomness, you can use the sign function. All this will just affect the colors of each single pixel. For example, we could say that we want less blue than the original. We are still keeping red, green and blue, but we are scaling the blue a little bit down. So it should be more yellowish, I guess. Now there's more yellow in the image. We can also base our new color not only on red, green and blue values, but we could read also the hue, the saturation and the brightness. Let's see that on the next episode.